Hello and welcome back to this is another episode of What Grows Your Perennials. In the last episode I gave you an outline of examples how different tree species align more to the heat of summer rather than the cold of winter, and pretty much my personal interpretations. In this video, I have several scientific articles, of which I am going to discuss 4 of them, so that you can see how the actual science have reported on this particular issue of your summer heat regime rather than your minimum winter temperatures. The first paper is a good example of how that it's not only the type of crop that you're growing, but also the variety. A lot of times we can think of people in tropical areas and they say, hey, we can grow oranges, we can grow pineapples, and us northerners say, well, can you grow apples? This is an apple variety that grows in northeastern Iran, and I found out that actually apples were developed down in that area. The phenological stages of apple tree in northeastern of Iran. Phenological, this word here, that means the physical stages. The main objective of this study was to evaluate the process of parameters such as the mean temperature, total precipitation on phenology and phenological stages of apple golden type in, this is a town in northeastern Iran. So, apple golden type, I'm thinking something like golden delicious, but I don't know for sure. Cultivating the apple for the first time was done in Iran, Greece, and Rome. This sentence is kind of a little off English, but apples tolerate the high temperature range of TPU and only in areas with winter temperatures reaching -40°C or regions due to warm air, cold air needed to break the winter dormancy. In other words, between -40, a low of -40 they can handle, and they need a period of cold to properly rest and break dormancy again in the spring. You need 1,000 to 1,600 hours below 7 degrees Celsius. So that is not really very cold compared to what we're used to here in Newfoundland. The proper temperature for germination in the field is about 18 to 22 degrees Celsius. And the apple is harvested at about 155 days to 160 days after flowering. So, 18 to 22, we'll bring up a calculator here now. 18 to 22 is midway, is 20. And it's a cool temperature crop. So, a -5. We're getting 15 GDUs per day. It said 155 to 160. So we'll multiply that 15 by 155 and we get 2,325 GDUs needed for the fruit growth and ripening. Up to 2,400. This is in Celsius. Here's your little map, and the area studied is this area in brown here. I'll zoom in on this a little bit for you. I showed this in my first video on growing degree days. So growing degree days is the sum of the maximum temperature plus the minimum temperature divided by 2, all minus the base temperature. That's your cool season crops is 5 degrees Celsius, warm season crops is 10 degrees Celsius. And because This is a scientific paper. They have a long explanation of what they do, so we'll just go down to results and discussion. And here is our first table. The name of the phenological process, the description, and the required heat units in degree days, the cumulative thermal units. The first, second, third, and fourth processes: bud formation, that is the initial formation of the flower buds. Bud break, just as the flowers are starting to open. Flowering is full flowering. And here is the period of fruit growing and the period of fruit ripening. So for bud formation, we need 32.4 heat units, a total of 32.4. So let's pull up my records from last year. And this column here is my accumulated growing degree units. Let's go up to January. Here's January the 1st here. I'm going to scroll down through. We don't have to pay attention. This is just what a 0.5 growing degree units in January. And a couple there. We'll scroll down to where the temperatures are actually starting to warm up and everything is starting to melt. Which, if we look at our high temperatures and mean temperatures over here, things are starting to warm up around here. So we have about 3.5 GDUs by the time things are actually starting to warm up. So we'll add onto this 32.4, we'll add 3.5. So you've got just over 36. Back to our GDUs 5, we scroll down to 36, okay, 35, 37. And that's April the 28th for bud formation, which is about right for what I'm used to with my apple trees. Another 80.4 after that, we get bud break, or 112.8 total, plus our 3, we're looking for 117, which comes in at right here at June the 1st, which once again still the same as with my apple trees. And now the full flowering at 186 plus 3, 189, 180. So now we're here at a week later, so around mid-June. This variety needs 119.77 for the fruit to grow. 2,163 growing degree units total. For me, if I were to scroll down there, all the way down, I don't get the 2,000 growing degree units. So this variety of apple would not ripen up here, would not even get to full size, let alone ripen. So the chances that any of the seeds in that apple variety would be viable is very slim. Therefore, that variety of apple would not naturalize in my climate. And then the actual total for flowering all the way to ripening is 2,786. Like I just said, even for these guys, the results of this study show that GDD in uplands is less than the amount needed to ripen apples and therefore excluded from the scope of the firm's cultivation. So they studied the amount of average GDDs for that area and decided that that apple variety would not be viable for them to grow in those areas. And that's going off of this map here. It's a map of growing degree days at 50% probability, so your average growing degree days. And you can see in the blue area here, you get 2,535 to 2,658. That is less than the 2,700 and whatever it was for the total ripening. In the dark green, they get maybe it'll ripen, maybe not. So once you get down to the light green, it's highly likely that you'll get a ripe crop, and in the orange and red, you definitely get enough heat for the crop to ripen. Studying the maps of phenological stages shows that southern and southwestern regions, in terms of supply of growing degree days, are very suitable for apple cultivation areas, and the period of growing apples is from germination to fruit ripening period from the 13th of March to the 3rd of September in these areas. But in the central and northern part, due to the higher altitude and lower temperatures, the phenological stages begin later than in the southern regions. In combination with the results of this study, it can identify favorable areas for apples in the studied area. And based on that, the date of cultivation and the amount of production can be progressed. I think that means estimated. And that's it for that paper. Now we're up in a paper from the Norwegian University of Life Sciences. This is a master thesis done in 2015. The phenological effect of climate on apple cultivars in Norway. Successful fruit growing is dependent on the good control of flower bud formation, knowledge on the timing of developmental processes in the tree and how these are related to each other in the Norwegian climate and in different cultivars. Here's our map of where the apples are cultivated. It just gives you a total cultivated area. And the cultivars for Norway, here the worldwide, the major commercial cultivars are the delicious golden red variants, Gala, Granny Smith, Fuji, John O'Gold Root, the Ida Red, I have one of those, the Champion, and the Elstar. For Norway, Braeburn, Elstar, Fuji, Golden and Red Delicious, Granny Smith, and Pink Lady are relevant cultivars for fruit import to Norway. So they don't grow as well there. There's over 200 apple varieties grown in Norway, but the best for production is the Discovery, the Summerhead, the Gravestein, Aroma, and their red variants. And here's an interesting thing to point out for those of us that's in high latitudes. Light is also an external factor related to FBF, and its effect should be discussed in terms of length, the photo period, length of your day, and the quality, the intensity. Experimental evidence supporting the effect of photo period on flowering in apple is scarce, and the most accepted hypothesis is that apple trees are day neutral plants. This paper confirmed a lack of photoperiod regulation of the growth cessation in dormancy in apple trees. In other words, the length of day had no effect on the growth of apple trees. However, they demonstrated that temperatures below 12 degrees Celsius consistently induce growth cessation. So an apple tree is not really growing much below 12 degrees Celsius. Even though they're active down to 5 degrees Celsius, there's not much noticeable growth until you get to 12. Here's a table of the different varieties that they were studying. The harvesting and ripening period: September, early October, early to mid-September, early to mid-October, late August to early September, early to mid-September, mid-August, harvesting from late August. So this lower dates here, they are the harvest dates, and this is the ripening period. And it's quite a few varieties there. Of course, this is our GDD calculation again. These tables is the analyst by date. For the shoot growth, remember I said that there was very little growth below 12C, so they're doing GDDs from 10C here, and your average temperatures, of course, and then as the temperature rises or falls, your accumulated GDD line will increase if the temperature rises and decrease in slope if the temperature falls. So here's a graph of the average of all the different cultivars, your growing degree units from 4 degrees Celsius. He's on the side going up here, and your green tip, when you notice the bud starting to grow, to the pink, and then full bloom. From green tip, they found the same as the guys in Iran did, about 35 to 40 growing degree units, and then you go up to the pink at 180 to 200, and full bloom from 220 to 250. This is their timing for the different varieties, and you can see it's during from early April to mid-April the green tip starts, and they're in full bloom by last of May. This is the graph for 2 separate years. Those are the varieties. So if I zoom in a bit more on the 2013 one now, you can see with different varieties, there's a couple of things you can tell here. One, this dark blue, I think it is, which would be the Gravestein. It starts growing at the lowest GDDs. It is not into full bloom until 175, whereas this one in the purple, dark purple here, which will be Franskar, it starts a little bit after it, but it's in pink before. The full bloom, they meet up together again. The same thing you can see with this maroon one here. The line actually, it starts below 50, but it's not until almost 250 before the pinks start, and the full bloom is just over 250, whereas one of the ones it meets up with, this purple one, is in pink at 200. So that's the difference between your different varieties. Here's a table where they give you the exact numbers for green tip, pink, and full bloom of the different varieties of apples. So now we're down into the discussion area. In the present study, similar results were found, and accumulated GDD over 10 degrees Celsius were strongly and positively correlated with the extension shoot growth. The physiological basis of this response is that cell division and growth are a temperature-dependent process. This is an interesting thing to point out with apples. Regarding the tendency to biennial bearing, which many of you, if you have apples, you probably realized, Jackson 2003 pointed out that the amount of flower buds formed also depends on the tendency of certain cultivars to produce large crop one year and a light or absent crop the following year. This is due to the inhibition of hormones because of the cost of actually growing and ripening a large crop of fruit. The average daily temperatures at which growth, cessation and differentiation of flower buds started in spurs and extension shoots was in the range of 15 to 20 degrees Celsius. This range is in agreement with the optimum temperatures of 13 to 20 degrees Celsius reported by these other papers for stimulation of flower bud formation under controlled conditions. Accumulated heat above 4 degrees Celsius as a growing degree days was positively correlated with the occurrence of different phenological stages of bud break. As discussed previously, this correlation is in accordance with the fact that processes involved in bud development, such as cell development and growth, are temperature dependent. And here's another thing about how many fruit, like I was saying in my last What Grows Here video. Moreover, dissections performed at the end of the growing season in 2013 revealed that flower buds on trees from, this is a location in Norway, were less developed compared to other locations and were the last ones to open the following spring. The negative effect of low temperatures on flower bud formation has also been reported by this guy in 1996 for Cox's Orange Pippin, and this paper for Summer Red under controlled conditions. So the cooler your fall, if you have a particularly cold fall, then it has a really negative effect on the flower bud formation. Some of you may know that the buds they formed the previous year, then they break and grow the next year. And this is where your winter kill comes in. My burning bush that I was talking about that I had to wrap up out there, it was getting a lot of winter kill, and because the flower buds grow on around the outside, I wasn't getting any flowers on them because every winter all those buds will be killed. The bush itself wasn't killed, but the flower buds were. And for apples, the authors found that temperatures of 13°C, I'm assuming 13°C or less, had a negative effect on both proportion of buds formed and the rate of development. And once again, he's referring back enhanced flower bud formation at increasing temperatures in the range of 13 to 20 degrees Celsius has been reported previously by the 1996-1997 papers. And right at the beginning of this conclusions, the results of this study have given insight into the timing of flower bud formation and its relationship to other developmental processes and the annual growth cycle of apple trees. FBF, flower bud formation, was first observed in spurs of actively growing trees between late June and mid-August at average air temperatures of 15 to 17 degrees Celsius. But by late summer, all spur buds that initiated flower buds had differentiated sepals on all flower primordia. FBF and extension shoots occurred after growth cessation, by late summer at average air temperatures of 11 to 15 degrees Celsius and extended throughout the autumn. On your older shoots between 15 and 17 degrees Celsius, flower buds would form during the growing period of 1 year, and the growing shoots, they wouldn't form until the shoot itself stopped growing, and then you get flower buds forming once again, and it's at between 11 and 15 degrees Celsius. So the length of your cooler spring and your fall dictates how well you're going to have your flower buds formed for your crop in the next year. That's the end of that paper. They were only concentrating on the flower bud formation and, of course, the flower bud break to full bloom in the spring. They didn't follow the fruit growth and ripening. But you can see by that, all during your growing season, your temperature regime has an effect on the bud formation for your fruit in the next year. Plant and site selection, genetics and the environment. This is a slideshow, a professor's slideshow from a talk at a agriculture college. So I'm going to click through this page at a time now. We're talking about matching crop or cultivar to the best site, or the site to the best crop or cultivar. Along with your soil characteristics, your plant characteristics, and your planting design, this is what we're talking about here, your regional and local climate. When you get into the local climate part, you're actually getting down into microclimates and maybe even the climate of your particular piece of property. This is the first part there. We're talking about apples, and they're in Kazakhstan, close up of Afghanistan, or Kazakhstan I mean. And here is the graph of this paper that I thought was really interesting. I'm going to zoom in a bit. This is the relationship of the number of accumulated heat units during 36 days after full bloom to the days required from full bloom to mature a Bartlett pear fruit. The warmer the post-bloom period, the shorter the time to maturity. You can see how it drops off. If you only add 170 GDUs, then you take 130 days for the fruit to mature. That is including, of course, those 36 days. If you add 333 GDUs in those 36 days, it would only take about 110. And of course, the warmer those 36 days are indicative of how warm the full 130 days would be, or 100 days if you had warmer weather. This slide is showing you your viticulture, that's grapes. What you would need. You need a GDD of greater than 50 degrees Fahrenheit, so that's warm season, that'll be 10 degrees Celsius, of over 2,000. So that's 2,000 GDDs in Fahrenheit. We can flip up our calculator again and do 2,000 divided by 1.8 equals 1,111. I don't get that. Let's see what I recorded last year for base 10. That's this one. And you can see I recorded 721. That is in my sunny plot, which is actually kind of exciting because what I'm thinking about now, my two grapevines there, that I say the grapes grow, but they don't get ripe. If I put a wall behind those, they get direct sun, and that would be in heat trap. I may gain enough heat in that area to get ripened grapes. So I got 721. I just need another 300 GDUs trapped by that wall. They need a long day length during the growing season, of course. I'm 49th parallel, so I'll get a long day length. Good air and water drainage, got it. Soil moisture deficit during growing season. That is one of the drier parts, so I won't have to worry about soil moisture. So let's go down to the next pages here now. Here they've got a table with the grape categories in 4 different categories. I don't know why there's not a 1 and 2 there. But group number 3, a Pinot Noir and a Chardonnay, they need 1150 GDDs. Now there's not much difference though, because 1150 divided by 1.8, see, that's only 638. And maybe I don't have the right grape variety there. I have to look into this and see. Yeah, I'm getting 638 there. 1300 divided by 1.8 equals 722. That table is telling me that I should be able to get the right variety of grape and grow it to full maturity, the fruit itself. Here we've got our ideal ripening temperatures. I guess it depends on what kind of wine you're wanting. Out in BC they make ice wine, and that's probably this light one here. So that was a little shorter one. This one, the phenological models of flower bud stages and fruit growth in Montmorency sour cherry based on growing degree day accumulation. This cherry is actually a very popular cherry both in commercial growing and in your backyard gardener. This is from the Journal of American Society for Horticulture Science. I don't think there is a lot in the beginning to point out. I think we have to go right to the results in this paper. Michigan is the leading producer of sour cherry in the United States, accounting for approximately 70% of the U.S. sour cherry production in the period of 1995 to 2004. And this is where you can see the west side of Michigan is where they grow most of them. Now I'll zoom in on this great table for you. So they put a base of 4 degrees Celsius. Cherries, as you know, they're a pretty hardy tree, and they flower first thing in the spring. So we'll look at the phenological stages here now, just a minute. Right here, green tip, stage 3. Tight cluster, stage 4. Open cluster, stage 5. First white, stage 6. First bloom, stage 7. Full bloom, stage 8. And petal fall, stage 9. So back here, they put in the line of best fit here. The stage 3, the green tip at about 25 GDUs. This is in Celsius now. It gets to stage 4 at about 50, stage 6 at about 75, stage 8 at 125, and by stage 150 it'll be at stage 9 in full bloom. which, once again, they were doing base 4, so I'll do base 5 here. I'm going to scroll back up to the spring, and they said 25 as a green tip, which will be late April for me, which is about right. 50 is the next step, which will bring us down to May the 12th. Full bloom 150 would bring me to June the 4th, and that's about right. Here they'll tell you the exact numbers. That was the graph back there. Green tip at 24, tight cluster 44. Petal fall, they've got 181. Full bloom 123. So that's during June we get our full bloom to our petal fall. Let's see where my petal fall will land according to that. 181. June the 20th, June the 7th. So in early June I will get my petal fall, which is about when I get it. Here is a graph of the fruit growth after the petal fall. So we're sitting somewhere around, from full bloom we had 150 GDUs up till full bloom. So after full bloom now we're going another 100. On the side over here we have percent of final diameter. It does have a stage here where it slows down, but it's fairly good relation to GDDs all the way through, right up to 100%. You can get 100% between 1,000 and 1,100, somewhere around there. Some fruit mature earlier, and this could be because they were more in the sun than the other ones. This table shows you the data. Full bloom, of course, that's been recorded every year, so that's why they have 21 years. They have only 6 years of side green, but these are their number of recorded years. The smallest size they have is 5 samples for that one. That's in the southwest. Let's see what we got here. Yeah, the open cluster is the one that's recorded the least, except for northwest we got the side green recorded the least. But we have a fair number of samples over the years to evaluate. And here is a very interesting table. I'll scroll down so I can read this to you. Model simulated versus observed fruit size expressed as a percent of final fruit size of sour cherry. They were able to calculate using growing degree days the size of the fruit. This Y, that's your percent of final fruit size, equals a minus 0.613228 plus 1.021062 times the growing degree days. And using that model, they got a 97% accuracy. They have the simulated fruit size here. So their model said that the fruit size should be 20%. And they go across. This one is right on. The black is right on here. The white is a little bit prior to it. But it's very closely correlated. If we go up to 80, CEC 1995 was right on the line, but Chess 1995 was not very far off. So almost exact correlation between your calculated fruit size and your actual fruit size, taking into account growing degree days. So if you were taking data at your site, then you can go to your past data, and let's go back up to this one, and we said it was about 1,000 GDD base 4 to 1100 for the fruit to ripen. So I go base 5 on mine, and we had to add the 150 to that, so we're talking 1100 to 1200 GDDs total. So I can expect my cherries to ripen somewhere around August 28th to September the 4th. If you find a average in your area, it will be different. And that's your fourth paper. Doing this research, well, it's always interesting to me, but it is exciting to find that my grapevines, it's only a matter of locating them in the proper area. I think they need a bit more heat, so I'll put a wall behind those two well-established ones. I have two more that I only put them there a couple of years ago, so they're not established yet, and I can move them. I am not certain of where to put them yet, so later on, come growing season, we'll decide on where to put those two grapevines. And for the other ones, cherry, I get plenty of heat for those. The pears, I get enough heat for those. Not a lot, but I should be able to get a ripe fruit. There was another one. Can't remember what it was. Anyway, I've never done a great job of presenting, but I hope you found it interesting and you hit that thumbs up button for me. If you want to continue to see more information videos like this one, make sure you're subscribed, and I'll see you in the next video.